Alright, so today we're going to be talking about theoretical and experimental probability and the difference between the two. So all the probability you have been doing thus far has been theoretical probability. Okay, so let's talk a little bit about the difference. Theoretic probability is probability determined based on reasoning. So if you think about a coin flip, we know that each one of those sides is theoretically equally likely to occur. So we would say the chance of either one of those things occurring would be a 50% chance or 1/2. Experimental probability is based on results of an experiment repeated many times. So the more times you repeat an experiment, the more accurate the results of that experiment will be, right? Because you're using a larger sample size, correct? So if you were to flip a fair coin 10 times, you have the chance of getting no tails or literally all tails, correct? And anything in between that amount. So theoretical and experimental probability don't always match up, but the more experimental trials you do, the more likely it is to match the theoretical probability. Does everybody understand the difference between the two? Okay, so these are the two formulas. Theoretical probability is number of favorable outcomes over possible outcomes, and experimental is number of times the event occurs over the number of times the experiment is done. So if we zoom in here, determine the theoretical probability of rolling a fair 6-sided die and landing on a 3. How many sides of a die have a 3 on them?
1.
Good, so 1 out of?
6.
Good, so you have a 1 out of 6 chance of rolling a 3. Now say you went to put this to the test. You did a trial of 100 rolls, and you realized that 20 of those rolls landed on a 3. What is your experimental probability?
20 out of 100.
Good, which reduces to give you 1/5. So you're going to notice most of the time experimental probability will not match theoretical, but the more trials you do, the closer you usually get to the theoretical probability. Determine the theoretical probability of picking a heart from a deck of 52 playing cards. How many of those cards are hearts? 13. Because it's 1/4 of the deck is each suit, right? So this would reduce to 1/4. So anytime that you pick a card from a deck of cards, physically, you have a deck of cards here, okay? If we were to just pick a card at random, well, I didn't get a heart, but what you could do is you could go ahead and oh, there we go, look. So you really have a pretty high chance on that one. 12 times a card is randomly drawn and placed back into a deck of 52 playing cards. On 4 occasions, a heart was drawn. Determine the experimental probability of drawing a heart.
1/3.
Good, yeah. So basically, you drew a heart 4 times out of the 12 draws. Now, it's important they mention with replacement, because if you didn't replace it, you'd have to do the consecutive denominators, right? Them depreciating denominators, okay? So this would give you 1/3. So any questions thus far? Pretty easy. All right. Our solar system is 8 planets. We don't include Pluto anymore, apparently. It's from the sun, it goes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, okay? So basically, we want to figure out what's the theoretical probability of selecting a random planet out of the 8 that is going to be closer to the sun than Earth is. So how many of those planets are closer to 2 of them out of the total, which is 8, which reduces to 1/4. So that's a theoretical probability. Now, could you use an experiment to trial this? How would you go about doing that?
You could, like, I don't know, make them out of paper and pick them.
Exactly. You could literally just, or you could even have like marbles and have like 8 separate marbles and put them in a bag and pull them out. Like, there's many ways you could test this experiment. Now, if 2 people did the same experiment based on a theoretical probability to test its validity, are those 2 people going to get the same results?
No.
Very unlikely they will, correct? So just keep that in mind. Theoretical probability is always the same. It's cut and dry. It is what it is. Experimental probability changes based on the trials, how many trials are done, the likelihood, the chance, all that stuff. After receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds that 992 skateboards have no defect. Selecting a skateboard at random, what is the probability it has no defect? So firstly, no defect is what over what?
992 over 1,000.
Good. Which would reduce to, good, 124 over 125. So that's the chance of no defect, correct? Which means, what is the chance of getting a defect? Good, 8 over 1,000, aka 1 out of 125. So if you were to go to this, company, whatever, the manufacturer, and you were to pull 1,000 skateboards, would that mean that you're going to exactly find 992 that have a defect? Not necessarily, right? Yeah, that's just theoretically based on, so some of these theoretical probabilities are going to be based on an experiment, but that doesn't mean that every time it's going to be that exact number. It just gives us a general idea of what to go for, okay? And then the last problem. So you randomly ask 500 households in your town if they have a dog. Of the 500, 197 responded they do. If your town has 24,800 households, about how many households are likely to have a dog? So firstly, what is the chance, or what is the probability that you select a house that has a dog right off the bat? So we got 900 and our
197 out of 500.
Good. So that's the chance that somebody has a dog based on the experiment. How could we then apply the experiment to the rest of the people in the town?
This divided by this, and you multiply it by 24,800.
Good. You multiply it by the number of people, and that's going to give you 9,771. What is this? Does this number mean that's exactly how many people have dogs?
Not really.
It's just likely. So the only way to be sure of that would be to actually ask each person in each household separately. But they did it the faster way, and they asked a few, and then they used the chance of that happening. Now, do you think this is really accurate way to do it?
No.
Not really, because just because somebody lives in the same area doesn't mean their chance of having a dog is going to be similar, right? So it may be different for something like, like what school you go to, because that has to do with the location. But having a dog, unless we found some significant data that showed that having a dog was related to where you live, probably not. All right, that's all I have for you today. Homework is really classwork, because